choice of steel is key as we strive for excellence in our shock absorbers. The materials selected for the tubes and piston rods meet the same criteria that apply to the materials we use to produce our OE quality wheel bearings. They guarantee optimal quality and safety. The robust process ensures continuous dimensional stability of the various machined parts of tube. All welds undergo 100% inspection to ensure the strength of the spring support welds, stabilizer bar bracket welds, as well as the other fastening elements. The machining of the rod is a step in preparation for grinding. The piston rod is induction heated to about 800 degrees, then cooled off to 40 degrees to fix the structure in place. This localized heat treatment makes the steel highly resistant to wear and impacts while the shock absorber is in operation. Grinding is a step in preparation for chrome plating. It guarantees a high-precision surface finish in the order of 1 micron to ensure that the chrome plating adheres perfectly to the rod. The shock absorber's piston rod operates in the environment of the wheel arch. Chrome plating enables it to withstand harsh external elements: salt, sand, water, gravel. The final polish provides a surface finish in the order of 1/10 of a micron. It enables perfectly smooth and silent operation of the rod for stable motion. These various precision parts are painstakingly assembled in a controlled environment. This key step creates the valve. It's the component that allows for the movement of the fluid damping. The process of combining the various components, piston rod, tube, valve, guide, and seal, is finalized by a crimping operation. Each shock absorber is subjected to several successive cycles of rigorous controls. Then, the nitrogen is injected into the expansion chamber of the shock absorber to displace the residual air. Under heavy demands, the gas maintains damping performance by preventing the formation of bubbles, a phenomenon known as cavitation. Surfaces are meticulously prepared for the application of high-performance paint, which protects the shock absorber against corrosion. Test benches enable us to develop the shock absorbers of tomorrow. One of them is used to test their performance. Here, we measure the damping forces as a function of the applied driving speed of the vehicle.